Are you guys going to do any of the singing telegrams sponsored by the music department this year for Valentine's Day? Yep, that's a thing.
No.
Okay, just thought I'd ask. So I had avoided these for about the last 2 weeks on purpose. So now that we're all comfortable with graphing, well, graphing is old news, but substitution and elimination, we're going to solve some unique types of systems today. So you'll see what I mean. You'll want to head these notes as systems, and then in parentheses, you'll want to put something like this: special cases. Every single system I've given you so far, even though we haven't talked about it, always like this, has been two lines that cross at one point. You could look back at every problem we've done for the last 2 weeks, and every single problem has an answer, a X and a Y, right? That's a point where two lines cross. So what's going to change today is we're going to get back now and talk about when we graphed. You remember how sometimes we had parallel lines and we said that they had no solution? And then we had overlapping lines and we said that they had infinite solutions. Today, we're going to look at that and see what that looks like when we can't actually see the lines. So I've got a handful of examples for you. There are two things on the plate today. Number one, I want to talk about special cases. And then number two, on this next assignment I have for you, I want you to start thinking about using any method that you wish. So rather than me giving you a worksheet and saying, solve them all by substitution or solve them all by elimination, I'm going to give you 20 systems or whatever and say, solve them however you wish. I think most often you're going to still choose elimination. It's just kind of what humans tend to do. But you are welcome to go back to the one from last, a while back, where we get one of the variables by itself and then put the box. And so some of you like that method maybe better. And so today you'll find opportunities where you can do it that way as well. I thought a day or two of just kind of some freedom of choice would be good for you to start to maybe dabble in when is it better to use this and when is it better to use this. But to begin the lesson, we're not going to talk about that freedom of choice stuff. We're just going to solve systems just the way that we're accustomed to. So for our first example, we have this. So going into this, I mean, I hope that you look at this and say, this is definitely a level 2. It's certainly not a level 1, because if you were to add the equations together right now, nothing's going to cancel. But it's definitely a level 2. How many of you are attracted to the X's? Or how about the Y's? Yeah, it just doesn't matter. And so what's interesting in a case like this is you're not going to get a lot of resistance on either of those. But more interesting is what happens after we make a commitment. So I'll take the first one I hear. Who should we kill, X's or Y's? X it is. And so check this out. If I want to kill the X's, then I have to be thinking about making this X right here that I'm pointing to, we want that to be a negative 12, right? Like this ain't our first rodeo. So what we're going to do is we're going to multiply the top equation by negative 4. And we're just carrying about our business. And for the first time now for us, we're going to see something unique, something that's not bad. It's just unique. So when we multiply the top equation by negative 4, I know we get negative 12 X's. What else do we get? We get plus 12 Y's, because we have to change the sign since we're multiplying by a negative, equals what? Yeah, positive 16. And now when we copy the bottom equation over, remember when we set out a minute ago to start this, we said we're going to kill the X's. But when we copy the bottom equation over, something should catch your eye. Again, our mission was to kill the X's. We made that choice. We could have said Y's and it would have been just fine, but X's, great. So when we add the equations together, we set out to say we're killing X's, and sure enough, we did it. Wahoo! How many Y's are left? They also die. When this happens, we're in one of these special cases. We're in a situation now where we're not going to have two lines that cross. We're going to have two lines that are in one of two categories. They either sit on top of each other or they're parallel. 100% when this happens, that's what that means. Okay, no crossy. They're either overlappers or parallels. So on the right side of the equals sign, what do we get? 16 plus negative 12 is 4. Now, that's not a proper math equation. That's not an equation. What is that? That's ghastly void equals 4. It doesn't make any sense. So in math, when everything disappears, we have a number to represent that. What is it? It is. 0 is the number that represents the absence of anything. Normally, I don't have you put zeros when things cancel out. We just let them go and move on our way. But in this case, I need the number 0 to hold the equation together like glue. Now, you have two choices at this point. You're going to be left, since all the X's and Y's have died, one of two things is going to happen. Either this is an equation that is true or it's false. There is no algebra. Like if I gave this to a fourth grader, they would look at that and I said, okay, little Marky, is that true or false? And little Marky would say, that's false. 0 is not the same as 4, right? So in a case like this, when the numbers that are left over are not the same, then we have what's called a contradiction. Cross out the equal sign, because that's what a person of principle should do. 0 does not equal 4. What do you think is the case with a system like this? Are these lines, do you think, parallel or on top of each other? Yeah, 0 doesn't equal 4. And you can sit here for as long as you want, a billion years, and say, I'm going to try to convince myself that 0 can equal 4. 0 just doesn't equal 4. It's not an algebra question. It's just common sense. For that reason, this equation system is impossible to solve. It's impossible to solve. Therefore, there is no solution. And this is the same thing we would have said if we were doing a graphing problem and we got y by itself and did our y equals mx plus b thingamabobber, we would see a pair of parallel lines in a case like this. Two lines that would have the same slope, but different y-intercepts, therefore never being able to cross. You with me? So the moral of the story thus far is that when you set out to kill one variable and they both just happen to die, you immediately have to shift into the mindset of, I'm not looking for number answers here. I'm not looking for parentheses and a comma. I'm looking for either this or the next example. Okay, so pay attention to those numbers that are left over. If they equal each other, great. If they don't, no solution. So let's take a look at the other side of the coin and see what that looks like. So again, it's not obvious. You probably just haven't been here. It's a pretty classic looking little baby level 2. Who should we eliminate, X's or Y's? Want to do Y's this time since we did X's last time? I don't care. I mean, you'll find you already kind of know the cat's out of the bag, what's coming here. So if I say I'm going to kill the Y's, what do I want to place right where that little red arrow is pointing? I want it to be a -6, and it's already a -3. So what do I have to multiply by? Just 2. Very good. Don't multiply by a negative this time because the signs are already cooperating. What will the new top equation be? And again, usually at this point in the problem, when you're first learning this, you're just kind of going through the motions. You might be chatting with a friend about something, talking to your mom about dinner. I don't know, because you're just kind of in robot mode at this point. So you copy the other equation over, ho hum, and then you just do what you set out to do. Our mission was to kill the Y's. So when we add downwards, how many X's do we get? None. Right. Cancel. Then the y's, of course, cancel. And remember what I said, in the absence of everything, we put 0. We don't like zeros unless we need them, and we need it here. We need a number to compare to the number on the other side. And what's negative 18 plus 18? And again, if I gave this equation to little Marky, the 4th grader, and said, little Marky, what do you think? Is this true or false? Little Marky would say, that's true. 0 is the same as 0. So in a case like this, I would not cross out the equal sign. I would let it ride and say, in this case, there must be infinite solutions. Before we press on to other examples, I'd like you to add something, please, to your notes for me. An equation system like this that has infinite solutions is called an identity. I don't know that anyone's ever going to ask you this. And an equation system like the one before that has no solution is called a contradiction. So you'll see these words pop up again kind of throughout your career in math. As an identity is an equation or a system that can't be true. Excuse me, an identity is one that's always true, and a contradiction is one that can't be true. So not too worried about those words. I just would like them to be out there so that if you see them pop up, then you kind of go, oh yeah, I remember those. So that was the first sort of part, the first thing I wanted to talk to you about. So let's take a look at another system. I want to take like a survey or a poll. I don't want to waste your time. I just would guess that most of you at this point really like elimination better. I know I do, but let's say that you really liked substitution. And when we switched from substitution, you were kind of like, you got a little peeved about it because you really like the box method. So I think you agree that a problem like this works well for substitution, right? Let's go back in time a week and a half. Why is this good for substitution? So I wanted to embark today on showing you that you can actually do systems now, whichever way you think is going to make you feel warm and fuzzy. So for the sake of notes in this lecture, I thought, let's do one by substitution because it's been a minute, right, since we've done that. So if we focus on this system, like Tegan said, we're obviously attracted to this X right here because he doesn't have any numbers with him. So if I were to take that equation, we're going in the way back machine here and get X by itself, what would X equal? Nice job. So 4y plus 10. And then I, of course, would box that up. Good morning. And I would put that into the bottom equation. Don't put it back into the top because that's the one we used. I know it's been a while. And we're going to take that, follow the red arrow now, and we're going to put it right into this bottom equation right there. So if I rewrote the bottom equation, I would write -2 awkward void plus 8y equals -18. And again, you're just carrying on. You're in robot mode, business as usual. And if you plug the red box contents into the awkward void, you get this. And you're still just cruising along, not thinking anything weird's going to happen. Let's distribute. What do we get? And hanging around me long enough, you know the answer to this question. What do we do next? Combine like terms. The -8y and the +8y on the left-hand side, when you add them together, look, they cancel. And so we find ourselves, it's a little bit of a different perspective on it. But again, we kind of got rid of the X by substituting, and then we got rid of the Y through no choice of our own. It just sort of happened. And we're left with this. And I'm sorry, there's nothing that should be difficult now about what you see on the board. No longer is this a ninth grade algebra question. This is now a fourth grade question. Does negative 20 equal negative 18? No, there's no X's or Y's to consider. There's no adding something to both sides. It's just a couple of dumb numbers. So I cross out the equal sign, and what conclusion do I arrive at, do you suppose? There is no solution. Very good. So again, when the variables cancel out, you either get an identity or a contradiction. In this case, it's a contradiction. No es posible. Still good? All right, let's do another one. And let's again take a look at substitution. I just want to continue to hit this a little bit just to kind of get it into your head that substitution, while it may not be our favorite method, is still okay. So let's say Levi really likes substitution the best, then he looks at a problem like this and he's like, yes, I get a chance to use my substitution, right? And so he's clearly attracted to that y that I've pointed at with that little red arrow. So if we get that y by itself, what would y say? Y equals what? 7x plus 2, right? And then we box that little sucker up, and where do we put it? There are no parentheses yet. In which equation? Second, right? If you used the first equation to make the box, you must substitute into the second equation. You've already done like 3 homework assignments over this, so this is old hat for you guys, old news. So when I rewrite the bottom equation, it says negative 14x plus 2 awkward void equals 4. And into the awkward void goes my box. Again, you're still just cruising along, multitasking. You're at home. You might be doing Snapchat with your left hand on your phone while you're solving this system. I don't know. And you're just rocking through. Here we go. When we distribute, we get negative 14x plus 14x plus 4 equals 4. And it just happens. We didn't control this. We didn't force this. It just happens. Negative 14x and plus 14x kill each other, leaving us with 4 does equal 4. 4 will always equal 4. 4 has always equaled 4. For that reason, what do we say? Very good. So I got a couple more examples, only 2, but the main ideas now are both on the table for the number 1, bless you, is that you can use either method depending on the situation. If you always want to use elimination, that's fine. There will be a section of a quiz someday where I ask you, like, you must use this method or this method, but generally from this point on, use whichever one you think is more appropriate to the situation. So that's idea number 1. And then idea number 2 is now we're going to start seeing weird systems where all the variables drop out and we're left with no solution or infinite solutions. So got a couple more examples on the back of the old note card here. Which method seems to be calling to us? Yeah. I mean, if you're really stubborn and want to use elimination, you totally could. But this one is already done for substitution because one of the variables is already gotten by itself. So I don't have to do the step where I pick a variable and get it by itself. It's amazing how often people overlook this. And it's like, dude, like it's right. It was given to you on a platter. The bottom equation literally says y equals a box. We're like, oh, well, thank you for that. Thanks for saving me a little time. And so where are we going to put that red box? In place of y in the top. Very good. So red box, follow the little red arrow. It's going to go boink right there. And that top equation now will say negative 20x minus 2 awkward voids equals 12. What's going to go in the void? Good. And today's worksheet is not all identity and contradiction problems. So just for the record, like you should just approach every problem in a business-like fashion. And when it happens, right? So let's distribute, and let's not distribute poorly. It's February 7th. We can distribute well. So we have negative 20x, and then what? And good. And you can already probably see it coming down the pike. The minus 20x and the plus 20x kill each other, leaving us with this statement, which is false. No solution. Okay. One more example. If I left this example out, I would certainly send the wrong message to you. So first off, and be interested to see what you say, which method are you feeling? Substitution is good in this case because why? Because there is a y that's by itself. Let's go back and do one by elimination, because it's been a while, right? If you want to press on and do substitution because you're all so good, please go do substitution. I'm going to make this system set up for elimination because I feel like it. So I'm going to take the top equation and I'm going to move some stuff around. I'm going to write the top equation as 7x minus y equals 9 because I feel like it. And you should look at that and not put it in your notes and like nod ahead until you agree with what I've done. All I've done is move the y to the other side, right? And then the bottom equation to follow suit, I need to just move the 3x, pull him to the left. So I wind up with 3x becomes positive, and then the plus 3y stays positive, equals 21. So to keep our lives as simple as possible, which variable is it easier in this case to eliminate? The y for sure. Because I'll point again with a little red arrow. I think to myself, boy, if only you were a negative 3. I can make that happen. So I'm going to multiply the top equation by 3. And that's going to turn my top equation into 21x minus 3y equals 27. And my bottom equation is going to be 3x plus 3y equals 21. I wanted to make sure to end the lecture with this problem because I didn't want you to walk away from this lecture and think that this is all we're doing today is the weird ones. This is just another business as usual, like an assignment 11 problem. It's just a problem. Let's add together. How many x's do we get? We do. So this is not going to be parallel lines or overlapping lines. This is just a normal one. The y's cancel. And then what's 27 plus 21? Divide both sides by 24, and what's x? 2. So you see that we're back now to a regular old problem. So my answer is 2 comma something. And where should I put the 2? Sure. Yeah, and you could go anywhere. I, for the record, would have 100% picked this one with the blue arrows because the y is by itself. But since you guys said that, and you're the ones that have to do this stuff, I'm going to go with what you said. So I'm going to go with the, I believe you said this equation right here, correct? With the gold box around it. So let's do it. Again, any equation is fine. So if I change the x in the gold box into 2, what will this equation say? 6 plus 3y equals 21. I was saying, Zane, I would use the one with the blue arrows, but since you guys had said, or I think Tegan had said, Tegan, I hear her voice a lot because she answers questions quickly, said she wanted that one. That's fine. So I just subtract 6 from both sides and get 3y equals 18. I divide both sides by 3. Done. So you're going to see a mixed bag today of problems where the terms are jumbled around like this, problems where they're already lined up, problems that are good for substitution, problems with no solution, problems with infinite solution, problems with one solution. It's just a big mixed jumbled mess. I knew that. I was testing you. It's not. Yeah. There. I would say there's no evidence. You can't prove it, but well, it is on recording, so you can prove that I did that. Yes, it's very easy to prove. Thank you. Any questions about any of that stuff? All right, good. Well, let me hand out the worksheet, and you can, if you're not quite done with yesterday's, you can wrap that up, but then I want you working on the new one today too.